Today we're going on to a new section in Chapter 4 on proportional relationships. We're going to make a lot of use out of proportional relationships in this class. And if you can get good at proportional relationships, there's all kinds of math problems that you can do pretty easily. So let's take a look. When filling her bird feeder, Sonia noticed that she paid $27 for 4 pounds of bulk bird seed. Next time, I'm going to buy 8 pounds instead so I can make it through the spring. That should cost $54. So a question for you is, does Sonia's assumption that doubling the amount of bird seed would double the price make at least some sense? What do you think? Yes.
Yes, I mean, it would make sense that it would cost the same if prices stagnate. If the price changes during the week, it would change, but assuming that there's not some mass hyperinflation.
Right. Or assuming that there's not like some discount for buying a lot. Sometimes that happens where you buy enough of something and it costs. Yes, you need to go get something to clean a mess. Yeah, there's paper towels right over there. They're not the most absorbent, so get a lot. They're more absorbent than a rock, but not a lot. All right. So it does make some sense, right? That if she doubled the amount that she was going to get, it would also double the cost. So I'll say yes to this question. So why? She's getting twice as much. It should cost her twice as much. So twice as much seed should cost her twice as much. And then go ahead and figure out, well, how much do you think that 2 pounds of seed should cost then? See if you can figure that out. I appreciate your thoroughness. I appreciate your thoroughness. Sometimes when people clean up a mess, they just kind of swipe at it, and she's doing a nice job. So, have you figured out how much 2 pounds should cost? Kiara, yeah. $12.50? I think you're close, but not quite. I don't think so. Jill? Yeah, it's $13.50. Because if she got half as much, it should cost her half as much. So we're going to take the $27 and divide it by 2, and that's $13.50. So to check her assumption, she found a receipt for 1 pound of bird seed. She decided to make a table, which is started below. Let's complete the table. So we just found that 2 pounds is going to cost $13.50. And she said that she believes that 8 pounds should cost $54, and that makes sense. So if we're going to find the amount for 3 pounds, there are several ways that we could do this, but since we already have these two items in the table, if we know the cost for 1 pound and the cost for 2 pounds, what can we do to get the cost for 3 pounds? Yeah, add them, exactly. If we add those two together, let's see, it's going to be 1950 plus another 75 will be 2025. And if we're going to get the one for 5, we could do this a couple of ways. What's one way that we could find the cost for 5? Yes, sir. I'm sorry, what? Multiplying what times what?
6.75.
Okay, we could take the 6.75 and multiply it times 5. See, that's 35 plus 2 is 37. 6 times 5 is 30, plus 3 is 33. There are 2 places behind the decimal. So $33.25. Yes. I can think of 2 other ways that we could find this using our chart. Yes, ma'am. Well, if you add the price for 3 and 4, that's going to give you the price for 7 pounds, isn't it? You want to try again? We're looking for 5. Shh. Okay. Well, you have lots of friends who want to help. Yes.
You can add 4 and 1.
Yeah, you could add the price for 4 and the price for 1. That would make a total of 5 pounds. So that's one way to do it. There's still another way to do it. Yes, sir? Yeah, add the price for 2 and the price for 3. Because that should give you the price for 5. Yes, sir?
Also, I think you did your math for multiplying 6.75 times 5 wrong, because it's 33.75.
2, let's see, carry the 2. I don't think so. Hang on a second. Hang on. What did I multiply wrong? 5 carry the 2. That's 35, 36, 37. What have I done wrong? 5. Carry the 2. 5 times 7 is 35. It's 37. Oh, there it is. Thank you. And one of the great things about having multiple ways of doing it, we could check it pretty easily by adding $27 and $6.75. That's $33.75. Thank you. Sorry it took me a moment to figure that out. Who thinks they can come up with what would be maybe the most efficient way to stand on your head and whistle off your socks? Well, that's what happens when you raise your hand before I've actually asked the question. I ask you to do something ridiculous. All right, tell you what, talk to your neighbor. What's an efficient way to find the cost for 6 pounds? Go.
No, just find the most efficient way to get 6.
right. Is anyone not ready? All right, my magic number generator has generated desk 8. Alexander.
I think it's double 20.25.
Yeah, because that's the price for 3. And we're pretty good at doubling. So that's what? $40.50? What would be a different way that you could do it by multiplying? Yes?
You could do 2 or 13.5 times 3.
Okay, you could do 13.5 times 3. Or, what's another way you could do it by multiplying? Yes?
6.75 times 6.
Yeah, you could do 6.75 times 6. All of those will work just fine. I think doubling the 20.25 is the easiest thing to do. So, how do the amounts in the table grow? Oh, we didn't fill in 1. What's the cost for 0 pounds? 0. That's an important idea. So how much do they grow for each additional pound? Right. What happens to the cost? Oh, don't everyone get quiet on me all of a sudden. What?
Each time you add 6.75 to the cost.
Okay, so the cost increases by $6.75. Make sense? Okay. Does the table confirm Sonia's doubling relationship? Where if you double the pounds, does it double the cost?
Yes.
So from 2 pounds to 4 pounds, yep, that cost doubled. From 3 pounds to 6 pounds, yep, that cost doubled. Yes, I'm not going to bother writing down which ones point this out, but that does happen.
I'm guessing there's no taxes.
At least theoretically, if it was taxed, the tax would double also.
Yes.
The amount of tax you pay is a percentage of the original charge. So since the original charge doubled, then the tax should double also. Now, the problem that you have with taxes is that when you really get into it, frequently it's, not a whole penny even, and so they round. And so sometimes that gets confusing. But we're trying to keep it as simple as possible here. But it's a good thought. All right, now let's look at a different situation. So, 5 years ago, Gustavo's grandmother put some money in a college savings account for him on his birthday. The account pays simple interest, and now, after 5 years, the account is worth $500. Gustavo predicts that if he does not deposit or withdraw any money, then the account balance will be $1,000 5 years from now. Discuss with your neighbor, do you think he's right or not, and why? Your neighbor. All right, finish up in about another 60 seconds. Don't worry about writing anything just yet. Just finish up your conversations.
He has to have money to get interest.
What's 500 divided by 5? What's 500 divided by 5?
No, this is what I'm talking about.
Yeah, but if he does not deposit any or withdraw, that means he can't put money in.
All right. That's time. All right. Shh. All right. I very much appreciate the spirited debate. So I think we can all agree on this first question. How did you think Gustavo made his prediction? Well, he doubled the time, so he doubled the money, right? Now, this question asks, do you agree with Gustavo's reasoning? I'm not going to try and get everyone's opinion on this. I'm going to give you mine.
No.
Okay, all right. Shh. And I'll explain why not. This is not the way simple interest works. All right. Shh. So let me tell you a very quick story. It's probably not a true story, but it illustrates a point. The story says that the man who invented chess was not very wealthy. But the king in the country that he lived in loved playing chess. And he said, ask me for whatever you like and I will give it to you. And the man who invented chess said, sire, I'm a simple man. I just have simple needs. So what I'd like you to do is on one corner of the chessboard, I want you to give me a grain of rice for that square. And then for the next one, I want you to give me 2 grains of rice. And then for the next one, I want you to give me 4 grains of rice. And for the next one, 8, and so on. And the king thought, oh, well, that's pretty reasonable. That can't be all that much. Done. And then the king went to his advisors and said, how much rice will we need to give to this person? And his advisors, who were better at math than the king was, said, oh, that's about our total crop for the next 7 years. It's a lot of rice. If you kept doubling it like that, that gets out of hand in a hurry. In fact, let's see. All right, shh. If you actually work it out, it is, don't need to write this down. Let's see. 223372037, and there's more decimal places than that, but 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. It's this many grains of rice for the last square. Let's see. That's millions, billions, trillions, quadrillions, 9 quintillion grains of rice. Yes, ma'am. Shh.
Like for the simple interest, like money add to the account from the bank,
Yeah.
but does it increase every year?
So, yeah, typically, and we'll actually do simple interest later, but what they do is if you're getting only simple interest, and almost no bank does this anymore, but if you're only getting simple interest, they take how much money you have in the bank and multiply it by some percentage, like 3%. And then they add that in. And then next year, you would get 3% on all of that money. So on the original that you put in and on the money that you put in. And you get what's called compounding interest, where you get interest on the interest.
So let's say like you had $1,000 in the bank, and let's say they gave you like 100 or something like that, and then you put like another 1,000, it would go like you had another percent of that money.
So what would happen would be like this. Let's say you put $1,000 in the bank. And just to make it simple, let's say that they paid you 10% interest. All right? So 10% of 1,000 is how much? Okay, it's 100, right? So then the next year, you would have $1,100 in the bank. And they would pay you 10% of that, which would be $110. So now you have $1,210. And then they pay you 10% of that, which is 121. So now you've got 1,331. Okay? The amount you get every year doesn't stay the same if you're really getting simple interest. Now, the example we're going to use, we're going to pretend like that doesn't happen. So, last week, Gustavo works, he gets, his money is in a really weird bank. It doesn't actually pay simple interest. He got a bank statement in the mail, and he was surprised to see a graph that showed that although his balance was growing at a steady rate, the bank projected that in 5 years his account balance would only be $600. He's like, what's going on? Why isn't my money growing the way I thought it would? So Gustavo decided to look more carefully at his balances for the last few years to see if the bank's prediction might be a mistake. So he put together this table. After 2 years, he had $440. After 3 years, he had $460. After 4 years, he had $480. After 5 years, he had $500. How has it been growing? Yes, sir. Pardon? Yeah, they had $20 every year. Each year. His bank balance increases by $20. And as I said, that's not the way banks actually work. They would give you a percentage, not a set, we're going to give you $20 every year. So, does Gustavo's money seem to be doubling as the number of years doubles? No. Two years was $440. But 4 years was not. What would it be if you expected it to double? $880. So is the bank's prediction a mistake? No. They simply pay $20 per year. So what he looked at then was a graph. And on this graph, he has the time after deposit in years and the bank balance in dollars. So there's more information that you can get from this than you can get from the table that we showed. For example, what is its starting balance? Where did he start? At $400. How much does it grow in 5 years? Well, we can kind of look up here. So how much does it grow? Oh, $500 is how much it has in there. How much did it grow? $100. Is it possible that Gustavo's account could have had $0 in it in year 0? Well, if you put $0 in a bank account, are they going to pay you for having an empty bank account? No.
And they would have like no percentage.
I'm sorry?
Oh, well, his bank didn't do that.
I'm sorry.
Oh, I was saying they would have no percentage, but I remember the bank doesn't do that. This one.
Yeah. So an empty bank account won't earn any interest. So really, this is more like a situation where Gustavo's grandmother could have given him $400 to start and then just give him $20 every year. It's not really how banks do business. Let's go on to page 3. So we're going to ask a couple of questions that we're going to answer by looking at these graphs. The question is, what makes Sonia's birdseed situation different from Gustavo's college fund situation? Why does doubling work for one situation and not the other? Consider this as you examine the graphs below, and let's answer these questions. So we've got our 2 graphs. Describe how each graph is the same. And when we're talking about the graph, we're actually talking about what we have graphed, not about the 2 axes. What's the same about them? Yes. Pardon? Okay, they both increase. And what we're going to say about them, did you notice that this is straight? It doesn't increase and then increase more and more and more. So they both increase at a constant rate. Gustavo's was $20 per year. And Sonia's was, what was it, $6.75 a pound?
Yes.
So notice both graphs are aligned. Now, what is it that's different about those two? Yes, ma'am. Say it again, I'm sorry.
Whose is this one? The left one?
The left one is Gustavo's.
Okay. His starts like higher and doesn't start at 0.
Exactly right. Gustavo's starts at 400. Oh, sorry, 400. While Sonia's starts at 0. Yes, sir.
Sonia's graph increases more rapidly.
Yes. Sonia's graph increases more rapidly, but does it actually? Or is it a lie of scale? How much does Gustavo's money go up every year? $20. How much does her Sonia's cost go up for every pound? $6.75. Notice that the difference between these is 100, and the difference between these is 10. So it makes it look like hers is going up more rapidly, but it is not. Right? It is steeper, but they're not on the same scale. All right. So with Sonia's, she starts with, if it's 0 pounds, she pays $0. If you double it, does that still work? Really?
Yes.
What's double nothing? Nothing. So she would still pay nothing. For Gustavo's, if we double the amount of time, is it going to double the amount of money? No. All right, we're not going to write that out. Here's the important part. The pattern of growth in Sonia's example of buying birdseed is an example of a proportional relationship. So let's go back up to this. This one is proportional. This is not proportional. To have a proportional relationship, you have to have two things. One is that they have to increase or decrease at a constant rate. There have to be a line. Both of these are lines. But the second part is also important. A proportional relationship always goes through 0, 0. If it's not proportional, it's not going to go through 0, 0. All right, so let's go on to page 4. Yes, page 4. We usually don't have ones this long. So, for each situation below, decide whether you think the relationship described is proportional or non-proportional, and be prepared to explain why you think that. Wow, there's a lot of those, aren't there? Tell you what, how about I give you a little bit of time to look at those and see what you think, or do you want me to do one first? You do one first? All right. So Carlos wants to buy some new video games. Each game he buys costs $36. Is the relationship between the number of games Carlos buys and the total price proportional? Well, if he buys 2 games, will we expect him to pay twice as much? Yes. If that doubling idea works, it's proportional. If he buys 0 games, how much is he going to pay? $0. It's important that it goes through 0, 0 also to be proportional. And for my reason, I would put, if Carlos buys twice as many games, he will pay twice as much. Let's look at B, and then I'll let you on your own from there. So a single ticket to a concert costs $56, while buying 5 tickets costs $250. Is the relationship between the number of tickets bought and the total prices proportional? I've already got some people shaking their heads. Why not? I need some new volunteers. Yes, sir. 250 divided by 5 is only 50, right? Or do it the other way around, 56 times 5 is not 250. So if he buys 5 times as many tickets, if it's proportional, it should cost him 5 times as much. So this is not proportional. Five tickets at $56 per ticket would be 56 times 5 is, I wrote 250 plus 30, $280. All right, let me give you a few minutes to try the rest of them. Feel free to talk to people who are close by you.
Depends on their birthday.
Well, so will you be 39
Really
and
just
I'll
depends on their birthday.
Yeah.
Yeah.
They'll be the same.
So we at
Got it.
4 years older than each other. By the end of the year, they'll be 4 years older. Don't know where yet. I put for you, yes. Why? No. I got the same cheat. Nice throw, Josh. Ah, you tell, but yes, for E, yes, I got what's 4. I think it's yes. Because it doesn't change. It doesn't specify it.
All right, take about another 30 seconds.
F is definitely
We have all the sunshine.
Warren, what did you prefer?
no.
I will. Thank you. Bye-bye.
If you double your age next year, you'll be what, 18? 24, you'll be 24. Will you be 24 next year? So it's not proportional.
All right, let's take a look at these. So I kind of left you with one that I think probably generated, from what I can tell at least, the most discussion about Vu being 4 years older than his sister. For me, the easiest thing to do is think about a graph. And it doesn't matter which one you put where. So let's say we put Vu's age and Vu's sister's age. When Vu's sister is born, how old is he? 4. And they're each going to add 1 each year, so it's going to look sort of like that. But since this doesn't go through the origin, which is 0, 0, this is not proportional. There are other ways to explain it, but that's the easiest way. Yes, ma'am. Shh. If it doesn't start at the origin, which is 0, 0, It cannot be proportional. And every year he's still 4 years older than she is, right? So let's say she's 4 and he's 8. Well, double her number of years. She's 8. Is he going to be 16? No, he's only going to be 12. Okay. All right. Let's look at this one. And this one I'm going to do a show of hands. Jana runs at a steady pace of 7 minutes per mile. Is the relationship between the number of miles she ran and the distance she covered proportional? How many of you think proportional? How many of you think not proportional? Quentin didn't think, so we get to try again. Everyone, one more time. How many think it's proportional? And not proportional? What? Jill thinks it's not proportional? It is proportional. So let's think about this one. If Jana ran 0 miles, how far has she gone? 0. Oh, okay. So when she gets to 7 minutes, she'll be at 1 mile. Is that going to keep going up at the same pace all the time? Yes, at least theoretically. So this is indeed proportional. All right, let's look at E. Carl just brought a music player and plans to load 50 songs each week. You can kind of tell the age of a textbook by the kind of technology things that they have in them. They're like, you're loading the songs on there? That used to be a thing. Oh, no, yeah, this is more like an MP3 player.
What? Those thingies?
Yes, those thingies.
I have a record player.
Yeah. All right. Shh. The great thing about MP3 players, honestly, is you paid for it once rather than having a subscription to something where you're paying for it for the rest of your life. That's why, I mean, for me personally, I liked having CDs because then you bought the music and then you didn't ever pay for it again. Yes.
What about those giant ones? It's like giant CDs.
Giant CDs, like a vinyl record.
A vinyl?
There's also they used to have these giant discs that had whole movies on them. It was called a video disc. Yeah. All right. Shh. Yes, sir.
Are we allowed to leave early because someone from orchestra just told us?
Yeah. Go. If you're in orchestra, go. All right. While they're leaving quietly, everybody else, we're going to go through these last few. Shh. While they leave quietly. All right. So he's getting 50 songs every week. Is that proportional? Yes, this is proportional. Because after 0 weeks, he's got 0 songs. Now let's look at F. So Anna has a new video game. It takes her 5 hours of playing to master level 1. After so much time, Anna understands the game better, and it only takes her 3 hours of playing the game to master level 2. Is the number of hours played and the game level proportional?
No.
What do you think? Shh.
Every time she plays the game, she's better at it.
Yeah, right. So the amount of time it takes her per level isn't the same all the time, is it?
No.
No. Now, is this going to go through 0, 0? How long does it take her to master 0 levels? 0 hours. It is going to go through 0, 0, but what's going to happen is, oh, that was annoying. there's a button on here that if you push it, I don't know why it's there, but it makes this thing go crazy. So it's 0 for 0, but then for level 1, it took her 4 hours. You get this sudden jump up here. But then for level 2, it took her 3 hours.
Wait, how about 5 hours?
I'm sorry?
5 hours.
Oh, it was 5 hours, not 4. Thank you. And then for level 3, do you think it might take her?
It's 3 hours. It's 3 or 4. You said 5 for this.
It's 5 hours for level 1
And 3 hours.
and 3 hours for level 2. That's what I've got.
It would take her 1
Wait,
hour.
which one's the hours? Which one is
Oh, sorry. This is level and hours.
I think it would take her 1 hour because it seems to decrease by 2 each time.
No.
Well,
What?
but can it keep doing that forever?
No.
No. So it's going to have to level off at some point. At some point, she's going to get as good as she's ever going to get, right?
1 second.
That long to.
All right. That's it for today.